Now let us look at how recursion uses stack. So I'll take this first example and show you how the stack is utilized. Now already we have seen this model of memory, that the memory is used by dividing into three sections. One is code section, and here I show stack, and this is heap. Now in my program I have two functions, that is fun1 and main. So the machine code of those two functions is already there in code section. Now let us run the program and see how the stack is created. See, the program starts executing from main function. So the first function is main function. In that main function, this is the first statement, that is X is created. So an activation record for main function is created, and it will have its own variable, that is X, having value 3. Then the very next statement is fun1, a call to function 1. So once the function 1 is called, it is having just one variable, that is n. This is the only variable. So activation record for that fun1 is created, and it will have that variable n, and this value X is passed to that one. So it will be 3. So this is for main and this is for fun1. I'm showing you line by line how it is working. Just let us look at it once more. See, the program start executing from main function. The very first thing is X. So activation record for main, and X is created. The value is 3 and the function is called. And that function is having just one variable, that is n. So activation record is created for fun1 with variable n and having value 3. Let us continue. If n is greater than 0, yes, this 3 is greater than 0. Then printf. So as per the tree already we have seen that a 3 is printed. Then the next call, function fun1 is called once again with a reduced value of n, that is decremented value n minus 1. So that function is called again. So once the function is called, we know that activation record will be created, and in that again variable n, and that will have the value 2 this time. This is also activation record for fun1, and this is the second call. Now in that second call, again it checks if n is greater than 0. Yes, 2 is greater than 0. So printf, so 2 is printed. The next line, call again with n minus 1. So right now n is 2. So again a new call, again an activation record is created, and variable n is created with value 1. And this is again a call for fun1. Now again, if n is greater than 0, yes, 1 is greater than 0, print 1, 1 is printed. Then again call fun1, with reduced value, decremented value, n minus 1. So again an activation record for fun1 is created, and it will have the variable n, and that value is 0. This is a call again for fun1. This time, as n is 0, when it calls again, n is greater than 0, so no, n is not greater than 0, it will not enter inside, it will not print anything. Here it doesn't print anything, and it will come out of this conditional statement. So it doesn't enter into conditional statement, so it will come out of the function. And once that call ends, this activation record is deleted, and the control goes back to the previous call. And in that previous call, what it has done, it has called this one. So the next is nothing. So that call will be using this activation record, and that also ends. So again this is also deleted. It goes back to the previous call. In the previous call, this line is over, so there is nothing remaining, and that call uses this activation record, but there is nothing to do. So this is also deleted, and this is also deleted. Then it come back to main. Inside main, after fun1, there is nothing remaining, so this also ends. So all these activation records ends one by one. So this is how stack is created and utilized in recursion. Now, one more thing. What is the size of the stack? Leaving main function, if you count the activation records 1, 2, 3, 4, so only for that function 4 activation records are created. So size of the stack is 4. And how much memory it's consuming? Each activation record is having just one variable, n. So n how many times? 4 times. So you can see the calls here, 1, 2, 3, 4. Already we have done 1, 2, 3, 4. So already we have done tracing. We have generated a tracing tree or recursion tree. So there are 4 calls. So 4 activation records are created. And at the end of this, it will go back and go back. So activation records are deleted again. So size of the memory consumed by this function is 4 into whatever the size of variable integer is. For value of x, that is n, is 3. For value of n is 3, there are 4 calls. So for value of n equal to 5, there will be 6 calls. So for n, there will be n plus 1 calls. So total n plus 1 calls. So how many activation records? N plus 1 activation records. So we can see that the activation records, number of activation records, depends on the number of calls. So total calls are n plus 1. And what is n? It's a variable. How much memory it's consuming? Now it is integer type. It may be taking 2 bytes or 4 bytes depending on the compiler. So we can say just n plus 1 call. So the total memory consumed by this is order of n. We can mention it as order of n. Why not plus 1 there? See, this is a polynomial, a formula n plus 1, in that degree of the formula is 1. Highest term is n. So we take n. So we write degree there, order of n or degree of n. So we mention the space as order of n. But actually if you see, it is n plus 1 activation records are created. So from this discussion we can understand that recursive functions utilizes stack. So here internally it takes some extra memory for the stack. So there are memory consuming functions. Recursive functions are memory consuming. So that's all I have explained this one. Now already I have a stack, then just I will show you how this function works. So I will use this program as well as a tree. Then also I will show inside the stack what happens. Let us look at it quickly. There are 2 functions, fun2 and main. Both these functions are there inside main memory. Now let us start executing. Program starts from the main function. So the first variable x. So activation record for main is created and having the value 3 in x. And it will call function fun2. Once the function fun2 is called, activation record for 2 is created. So it means all these are for 2 now. So I'll just change them. So the first call, n equal to 3, this is created. That is this one. This is created. Now n is greater than 0. Yes. Then call again. So again it will call with n minus 1. So a new call will create this activation record with n equal to 2. Then again it will call. Then again it will call. See, because the first statement is call. So it's calling itself every time. When n is equals to 0, 0 is not greater than 0. So it will not enter into if block and come out of the function. Once it come out of the function, this activation record is deleted because the function with value of n as 0 has terminated. It goes back to the previous call. In the same function, it will go back to the previous call where it has finished this one. Now it has to perform this. That is this line in the tracing tree. So what is the value of n? It has to print. Now the current topmost activation record is this one where the value of n is 1. So it will print 1. It will print 1 because the value of n is 1 here. And once it has finished, it will come out and this activation record is deleted. It will go back to the previous call. In the previous call, again it has finished the first line, that is this line. Now it has to do this. So print n. So what is the value of n now? So the topmost activation record in the stack, you can see now n value is 2. So this is printed. So 2 is printed. Likewise 3 is printed and all these activation record ends. So you can see that these activation records are created when the function was calling itself again and again. So this is more like ascending. Now once it has reached the last call, that is where n is 0, so it will start returning. So that is a descending. So while descending, it will utilize these values. So all the values of n are there in the stack in the different activation records. So these values are utilized at returning time. So that's all. This is how recursion uses stack. So both of these functions are almost same, only the difference is that this is first printing and then calling, this is first calling then printing. So the activation record created for these functions will be same only. So that's the reason I have taken two similar examples and I have shown you how the stack is utilized. It will be same in both the programs. The size of the stack and the space consumed by this function is also order of n, that is total n plus 1 activation records are created for function fun2, leaving aside main. This is how recursion uses a stack. Now next thing that we have to study is how to find the time complexity of recursive functions. So I will take just one example, this example, and show you how to find the time complexity of recursive function.